Alright, today my lecture is on congruent figures. This comes from chapter 4.1. Our learning target is to become con artists, which is a terrible pun, I apologize. And what congruent figures are is that they have the same size and shape. So they can be slid, flipped, or rotated so that they move exactly onto each other. Slid is something I just showed you. Basically, if they're congruent, they slide one right over the other, and it completely covers it up. Flipped, imagine that you have a line right here, and it's going to be a flipped. It's like a mirrored image of the other. I can't actually do that one for you. And then rotated. If I rotate this one, it moves exactly right over the other, so you can't see it anymore. Now, congruent polygons are the same. They move over each other so that they completely cover each other up. And they have congruent corresponding parts. So both angles and sides are congruent. Matching vertices are corresponding vertices, so you must always write corresponding vertices in the same order when naming congruent polygons. Take a second, pause the video, make sure you have that in your notes. Moving on. Now, if I tell you that these two are congruent, it's kind of hard to tell unless you rotate them in a way so that it's a little bit easier to see. Let's see. So what I did is I just rotated them so they look like mirror images of each other. And you can see that angle D and angle F, or point D and F, are corresponding. And then, so I wrote those two down first in the triangles. Then I said moving on to J corresponds to C, so I put J and C second. And then moving on to T, that corresponds to R, so I listed those two last. They have to be in the order according to the first triangle that you write down. So if I have written down triangle TDF, I would have to written down RFC, going in the same order around the triangle. Then I have to know that I have 3 congruent sides and 3 congruent angle pairs. So what I know is that DJ is equal to FC. So I'm going to make those congruent by putting just a hash mark in there. Angle, or side length JT is equal to side length CR. So I'm going to put 2 hash marks right there. And then TD is equal to RT. And I'll put 3 hash marks right there. Now I have my 3 corresponding congruent side pairs. Now I need my angle pairs. Angle D is equal to angle F. So I'll put a little arc in there. Angle J is equal to angle C. So I'll put 2 marks in there. And then angle T equals angle R. So 3 marks in there and 3 marks in there. Once I know I have 3 corresponding congruent side pairs and 3 congruent corresponding angle pairs, then I know that the whole triangle is congruent. Third angle theorem. The book calls this theorem 4.1. I call it the third angle because if 2 angles of one triangle are congruent, these 2, and 2 triangles of another, right here, then the third angles are congruent, meaning that angle C and angle F are congruent. So let's just say that angle B is 50, angle E is 50. Angle A, let's say it's 30, angle D is 30. Here's a way off, but I'm just making up these numbers. 50 and 30 is 80, with 100 left over for the third angle. Same thing over here. Has to be 100 left over for the third angle for them to add up to be 180. and therefore they are congruent in every case. Question 1, you're going to do this one with me. Are these triangles congruent? Why or why not? Well, I'm looking for 3 corresponding congruent side lengths and 3 corresponding congruent angle pairs. First thing I know is that AB is equal to 3, and so does EB, so they're equal to each other. BC is 4, and so is DC, that's 4. And then, because of the hash mark, I know that AC equals EC. I don't know the length, but I know they're equal. Angle A is equal to angle E. They both have just an arc in them. Angle B is 90 degrees, and so is angle D. And then I know that ACB, this angle right there, is equal to ECD, this angle right there, because of the third angle theorem, or also because I know that these are vertical angles. Therefore, I have 3 pairs of sides and angles, and therefore they're congruent. Moving on to question number 2. I want you to do this one the exact same way on your own. Stop the video and ask Mr. Duffy if you need help. Keeping going. Given that the polygons are congruent, find the missing sides and angles. Now, what I like to do is either redraw it, or because I can do this, I can just rotate it. But if I were you, I would redraw it in a way that it looks like they are congruent with this one rotated. And then I can see easily that this side is equal to this side, so they're both 3. And this side, 7, is equal to this side, so that's also 7. And this angle, 55, this is 55. That's 125, then this is 125. And the only thing that I'm missing is this angle right here. Well, I know that if it has 4 sides, I subtract 2 and multiply by 180 to get the interior angle sum. So all 4 angles should add up to the 360. Then, if I know 3 of the angles, then I subtract the sum of those, and I'm left with 145 degrees as my unknown angle right there. Moving on. Pause the video, do this one on your own. Make sure that you realize which sides are corresponding to each other, set them up equal to each other, and solve for the value of A and then also the value of X. Moving on, we have a proof for number 5 and number 6. Number 5 I'm going to do with you, and you'll have to do number 6 on your own. So I'm given that PQ is equal to PS. So that's the first thing I'm going to write down in my proof, and that's given. They both have a hash mark. Then QR is equal to SR. They both have 2 hash marks, and that's given. Easy. Then the last thing I know is that PR is equal to PR. It's one side that's shared by both triangles. Now, if I have anything equal to itself, I know that's because of the reflexive property. That's when we use this. Next, after I've gone through the side pairs that are the same or congruent, I need to have congruent angle pairs. So I'm given Q is equal to S, or congruent to S. They both have 1 arc. That's given. Then QPR is equal to SPR. QPR, SPR, they both have 2 arcs in there, and that's given. And then I know that QRP, this angle right here, is equal to SRP, this angle right here. And that's because of the third angle theorem, telling us that if we know these 2 are equal to these 2, then the last are equal to each other. Then I say, well, one triangle is equal to the other, because that is the definition of congruence. All 3 sides and all 3 angles are congruent. Now, what you'll notice is that I didn't write them down in the same order as they asked me to. That's okay, as long as you write them down in the correct order according to each other. So Q corresponds to S, P corresponds to itself, and then R corresponds to itself. Number 6, you're doing on your own. Please write down as statements and reasons. Make sure that you've written down all three side pairs and all three angle pairs. Tell me the givens, and then also tell me why for the third ones, for the ones that you don't know. And if it's helpful in any way, you can take this. What I'm doing is you can redraw it in a way that shows things a little bit easier. And what you see by these arrows is that they are parallel. When you have parallel sides, quite often you're going to have alternate interior angles. So that's just a clue to help you out with this one. Question 7, a little bit of help right here. This isn't too bad, but LC corresponds to the bottom. As you can see that these two are just reflections of each other, LC and BK. JB, so J to the B, well, what corresponds to J is M, what corresponds to B is L, so it's going to be M to the L. Angle K corresponds to angle C. CML, well, if I have CML, what corresponds to C is K, what corresponds to M is J, and what corresponds to L is B, so it's going to be KJB. And you can probably do the rest. Ask Mr. Duffy if you need any help. Moving on. Question 8 is a little bit tricky, but all you have to realize is that it is very similar to this one. So what you can do is make sure that you have drawn in everything. That you know. Meaning that the top is going to be 36 and that the bottom is going to be 54 and that this side right here is 34 and this side over here is 33, and then the angles, the upper left is 103 and the upper right is 105, lower left is 77 and the lower right is 75. And just make sure that you are answering the questions based on that. Are the triangles congruent? Justify your answer. Number 9, I like to do proofs just to make sure I get everything. Now, if they're congruent, that means that all three side pairs and all three angle pairs are going to be congruent. So, RT is equal to U, and that's given, UT. RK is equal to UK, that's another one that's given. TK equals TK, why? If they share the same side and we're saying something equals itself, reflexive. Angle R equals angle U, well, that's given. They both have one arc. Angle RTK equals UTK, that's also given. They both have two arcs. And then angle RKT, RKT, 1, 2, 3 arcs is equal to UKT. This, and that's because of the third angle theorem. And therefore, because of the definition of congruence, those triangles are congruent. Number 10, I'm leaving this one to you. Number 11, I'm leaving this one to you. And number 12, I'm leaving this one to you. This is a congruent statement right there. Good luck.